Got his 3-number lock combination. Boom. What should you put down to help you? 3 blank spaces. Okay. 1, 2, 3. He knows the lock only has numbers 0 through 29 on it. How many numbers is 0 through 29? 30 total. Okay. He also remembers the first number is a 5 or a 15. 5 or a 15. How many choices do we have for that first place? 2. The second number is odd. So if I have 30 total, how many will I have that are odd? 15, because you divide it into the 2 groups of odds and evens, which is 15. So that 15 goes here. And the third number is 22. Oh, wait. Do I put 22 there? 1. Yes, that's my mistake. It is 1 choice that is the number 22. It is 22. So that is 1. Okay? So, how many possible combinations are there? What would I do to get my final answer? Multiply. 2 times 15 is 30 times 1 is 30. There are 30 combinations, given those hints and restraints. Okay? Number 2, you're reaching into a box of 8 markers. You have 1 yellow, 1 blue, 1 black, green, red, orange, purple, and brown. What is the probability you pick a black or brown marker? A black or brown marker? Yes. So when it is an or statement, we want to get as many as possible. This is not on a table, but it's the same. So the black marker, it's a probability. That's 1 out of 8. Plus the brown marker is 1 out of 8. When you add fractions, you keep the same denominator and you add the numbers on top, which is 2 out of 8. You could also reduce this to be 1 out of 4, but I would take either. Okay? Does that make sense, Brianna? Does that make sense? Yeah? Does that make sense? Okay. Any questions on Bella Work 8? All right, let's jump right into conditional probability. Turn in your notes to conditional probabilities. Oh, let's call Devion back in. Oh, Camille, can you, since he's got a leg issue, I send him out for the skills check. It's a good thing I remember that. He'd probably be out there all day. Is he there? Okay. All right. Conditional probability. Conditional probability. What is conditional probability? Okay. I'm going to say CP, conditional probability, is where the probability of an event, is conditional. Come on, let's go. Devion, put that away. Is conditional or dependent. Dependent, because I know you're not supposed to use the same word, on another event. Okay? So yesterday we talked about compound probability. Those are just individual probabilities that we multiplied. Today we're talking about conditional, where a probability is dependent on knowledge of something else, of another event. Okay? Okay? And the big takeaway, big idea, as we look at the next statement, is this little vertical line. This is conditional, okay? That vertical line means given or given that. Given or given that. I say given that. Most of the other math teachers say given. Okay? Please put it away. So here is the statement. And we're translating. So it says, what is the probability of selecting a 6-foot tall person? I'll say player. 6-foot tall. No, I'll say person. Person. And then there's that vertical line. Given that they are on the basketball team. Okay. So the actual translation, what is the probability of selecting a 6-foot tall person given that they are on the basketball team? Okay. So the condition here, come on, Charles. The condition here is they have to be on the basketball team. Okay. They have to be on the basketball team. They have to be on the basketball team. So, do I have anyone in here that plays basketball for Pike? One? Just one? Okay. So, in this case, we would have 1 in my denominator. That becomes your denominator. Whoever is in the basketball team. And then, as I look at that 1, is TJ over 6 feet tall? No. So that would be 0. So that probability for our class, 0 divided by 1 is 0. Okay? All right. So again, the big difference is the condition, which is following that vertical line. Number 3, what's the difference between the following statements? What's the probability of a red car given that you're looking at 2-door cars? Okay? So here you are looking at 2-door cars. That's your condition. Okay? You're looking at 2-door cars. And of all those 2-door cars, what's the probability of getting a red car out of those 2-door cars? Whereas here, what's the probability of getting a 2-door car given that you're looking at red cars? So here we are looking at just red cars. Looking at red cars only. And of those, what's the probability of getting a 2-door car? Okay? So let me show you a picture. Does everybody have that written down? So the first one, we're looking at the condition of 2-door cars. And of all those 2-door cars, we're looking at red cars. And the second one, we're looking at all red cars. And then we're looking at 2 doors of those. So take a look at these pictures. Okay. Which of these is showing number 1, the first one, where I'm looking at all two-door cars and I'm trying to find the red car? The one on the right, yes. These are my two-door cars, and let's focus just on these 4 because I can't count all those. There's only partial ones. So as I count those, okay, as I count these, and I'm focusing on these first 4, how many two-door cars do I have? 4 that I'm focusing on. And then of those 4, how many are red? 1. Which means this one belongs to the second. I'm looking at all red cars. And how many red cars do I have in this picture? 3. And of those red cars, how many are 2 doors? 2. Yes, this one here has a 4-door. So that's the difference. The condition part is what falls behind that vertical line. Does that make sense? Do you see the difference? Okay. I was so excited to find those pictures. All right. No, we don't want that. Let's go back to screen share here. Okay. So those are the differences. So number 4. Number 4, what is the general calculation for conditional probability? Here it is. The probability of an event A, given that B happens, or given that B happens, is equal to the probability of A and B happening given that B, or over B. So notice whatever is behind this vertical line, I say you turn it into your horizontal line, and this becomes your new denominator. New denominator. That only happens when you have that vertical line. Let's take some notes. Come on. So let's see this in practice. And remember, when we have A and B, it's where they intersect, right? Okay. So let's erase these. All right. So this is a conditional. Conditional. We have this given. So my dance here, here's my vertical line. I want all people who dance. All people who dance. So find dance, go to the end, and this is now my new denominator. But wait, Miss Thede, I thought you said for a two-way table, it's always the total. It is, unless it's conditional, okay? If it's conditional, you're always going to put whatever comes behind the vertical line as your new denominator. Now, we want all women who dance. So you find women, and you go over here. But remember, we want all women who dance. So where they intersect, remember, it's an intersection, is right here. So that is 16 out of 18. And that is your probability. Okay. Let's take a look at the one behind it, or just below it. This time, we want the probability that someone likes to dance given that they are a woman. This is conditional. So, given that they are a woman, I want all women here. So, find all of your women. That's going to be a denominator of 30. And now I want women who dance. Still that same 16, But they both, the one above and this one, have different denominators because what follows, they have to be a part of that group. In the first one, they had to be in the group of dancers. In the second one, they had to be in the group of women. Okay? Now, the probability of the next one. What does that little squiggly symbol mean? Not dance. Is this a conditional? Do you see a vertical line there? No, it's regular probability. So what is my bottom denominator going to be if it's regular probability? 50. Yes, that total. So this one goes over 50. We know that. And if I'm looking for not dance, first of all, I want to know what's the probability that someone does like to dance. So let me do some erasing here. Let's go to dance is 18. 18 out of 50 like to dance. Well, you either prefer dancing as your favorite sport or something to do, or you don't. So to find this, what would you do? Right. Take 50, your total amount, minus the 18 that like to dance, which leaves you with 32. 32. Because the 18 who dance plus the 32 gives you the 50. Any questions on that? Does that make sense? Because I think people still have problems with the not. Okay, let's look at the next one, the second column. Probability that someone prefers movies given that, that's that conditional, they are a man. Well, if it's conditional, you need to look at all men because that follows that vertical line. So all men would be 20. And then they also have to like movies. And so the intersection of that is 8 out of 20. Let's see if you can do this next one on your own. What is the probability of selecting a man given that he also prefers sports? See if you can do that one on your own. What's your bottom denominator going to be? What is it?
60.
Say it one more time.
60.
Yes. Good. What is it going to be, class? 16, because you look at all of sports, and then you look where the men are. So the men who are part of sports, where did they cross? Should be 10. How many had 10 out of 16? Nice. Are you guys just not raising your hand, or you didn't get it? Or you didn't do it? You got it? Okay. Charles, does that make sense? Now, what about this one? Is this conditional? No. So what's my denominator going to be for this one? 50. It's back to regular probability. So the bottom number is going to be 50. And is that dance and men, or is that dance or men? That is and. Remember, you say it quickly. Dance and men. It looks like an N. So, dance, men. What is my numerator for that probability? 2. We want dancing men. And that is my probability. Questions on those? All right. Let's see. All right. here's what I'm going to do. I'm going to stop for today, but I want you to work now. You have that homework, okay, on Canvas. This is homework number 3 on Canvas. It was supposed to be due tomorrow, but I'm going to make this due on Monday. But I want to see people out with their computers and or phones. Okay? I do want you to be working on this now because we've got about 7 minutes. Don't hit submit unless you are ready to totally turn it all in. But it should, if you don't close it, it should keep what you are at. Okay? Devian, you don't have any other study hall? Which one? I can't hear you.